All right, here we go again. So, okay, we're talking about initial conditions. And we'll try to explain what that is as we go. But the thing that we've been doing is we've been working with antiderivatives for the first couple days of this new unit. And the question that they've been driving you crazy is this one. What is that C? What is the plus C? What does that mean? And initial conditions is going to help us answer that question as we move forward. So, without any further delay, let's get to it. Initial conditions. So to find out what C is, we need just a little bit of information. Let's go full screen. It's nicer. So we need a differential equation, which is just an equation that has a derivative in it, okay, and an initial condition. So here's my differential equation. It's an equation of a derivative. We can rewrite that if you like. I'm going to rewrite that as, instead of g prime of x, I'm going to think about that as dy dx. Okay, and so dy dx is equal to 6x squared. We're going to change that into that differential form. Remember, we used that prior to starting this unit, the very last, so we've now used differential form. And we can then integrate. So we integrate, and on this side we get y, and on this side we add 1 to the exponent divided by the new exponent, so we get 6x cubed over 3, so I think that's 2x cubed plus c. Now, I told you today we'd figure out what the plus c is, and we're just going to use this information, this right here, this initial condition, to figure out what c is. And so we know that when x is 0, y is equal to negative 1. So we use that information right there. When x is 0, y is equal to negative 1. So negative 1 is equal to 2 times 0 cubed plus c. And if you stare at that for quite some time, you'll come to the conclusion that c must be equal to negative 1. And so my equation, y equals 2x cubed minus 1. Okay, they're not all going to be quite that easy and obvious, but that's the one we come up with. And really, we should probably write this instead of y, we should rewrite this as the g of x. All right. Poorly done. But anyway, that's the idea. So we just take the antiderivative, we use the initial condition to figure out what c is, and we've got the exact function with which, whoa, that's insane. See anything move that fast? With which we made this work. Let's go to number 4. So here's another example where we're given a second derivative, then we're given an initial condition about the first derivative, and then we're given an initial condition about the function. So we're going to do this in 3 steps. Okay, it turns out that the antiderivative of the second derivative is the first derivative. Makes sense, because the derivative of the first is the second. So we're going to anti-differentiate 2 dx. When I anti-differentiate 2 dx, we get 2x plus c. Now we use this initial condition, because what we found here, f primed, is equal to this. So f primed is 2x plus c. So working with f primed, we know that when x is 2, f primed is equal to 5. So 5 is equal to 2x plus c. Oops, not x. What did I do? I don't want x. Oh my goodness, what am I doing? I want an eraser is what I want. There it is. Moving rather slowly. Now I want a pen. Pen, there we go. So 2 times 2 plus c. Meanwhile, you probably have already figured out that c is equal to 1, right? So now, my f primed, I'm having a hard time today. My f primed, you'll have to forgive me, is equal to 2x plus 1. And f is the antiderivative of f primed. So it's the antiderivative of 2x plus 1. So we use our little rule. We add 1 to the exponent. This is to the first, becomes the second. Get 2x squared over 2, which is just x squared. The antiderivative of 1 is x. And then we've got plus c. We've got another initial condition right here that we'll use to figure this thing out. When x is 2, y is 10. So 10 equals 2 squared plus 2 plus some mystery number. 2 squared is 4. 4 plus 2 is 6. 6 plus what equals 10? Hopefully the answer is 4. Okay? So then we write the actual function, because that's really what we're after, is try to find the function. F of x equals x squared plus x plus 4. Okay? And if you just work your way back through, you know, do the derivative. Derivative of x squared plus x plus 4 is 2x plus 1. That's good. The derivative of 2x plus 1 is 2. That's what we started with. We're all fun and nice and good. Okay? So we're just using some information, a little algebra to figure out what the value of c is. All right, so back to a little fun with physics, and that also comes into things. Remember back in the day when we did position, velocity, and acceleration, and we said the velocity is the derivative of position, and the acceleration is the derivative of acceleration. What did I just say? Acceleration is the derivative of velocity. So it works the other way when we're integrating or finding the antiderivative. If we know the acceleration, we can get the antiderivative to get the velocity, and we can take the antiderivative of that to get position. We'll use some initial conditions to get there. So if you look, derivative of this is that, right? So true, you get that. Derivative of at plus some feet, some number is a, and if we work in the other direction, you know, at, and then this is my initial condition, and then this is my initial condition, and that needs to have a t in there, doesn't it? Yes, it does. Huh. Okay, plus v naught t plus h naught. Make sure you fix that. All right, so here's a little story for you. Okay, that man in a red suit up in a hot air balloon. It's rising at an initial velocity of 16 feet per second. It releases a sandbag when it's 64 feet above the ground. So right there, at 64 feet, this is the ground, of course. It's full covered ground apparently. 64 feet above the ground. How many seconds will it take for the bag to hit the ground? And of course, what is its velocity just before impact? Okay? So here's what we know. We know we have an initial velocity of 16 feet per second. We know we have an initial position, h sub 0, of 64 feet per second, or 64 feet. All right. So we know, since we're talking about feet and all that sort of thing, that my acceleration is 32 feet per second, and it's negative. Okay? So there's where we start. If we want to get a velocity, velocity is the integral of acceleration, which is the integral of negative 32, which is negative 32 plus some constant, and the constant in this case is going to be my initial velocity. Okay, negative 32t. Okay? So, free naught. So, my velocity is negative 32t plus 16. Okay, and it's plus because we're rising up. So we've got initial velocity upward of 16. We've got acceleration moving downward at negative 32. So what else do we need to know? Release the sandbag how many seconds? So we need to figure some things out. We've also then can get our position function, which our position is the antiderivative of velocity. So it's the antiderivative of negative 32t plus 16, SDT. Negative 32t squared over 2 is going to be negative 16t squared plus 16t plus my initial height, and we know my initial height to be 64, so that's good news. Okay, so a couple things we need to figure out. How many seconds will it take for the bag to hit the ground? So we know its initial position is right there. The bag is going to go with gravity, so we need to figure out when it's going to hit the ground. That's what really that means. And then we want to find out the velocity, so we'll have to jump back to this equation. So when, first of all, is negative 16t squared plus 16t plus 64 going to equal 0. When is that going to happen? Well, I don't know, but I'm sure I can figure it out. And these all have 16s in them, so if I pull a negative 16 out just to see if it factors, t squared minus t minus 4, that's not going to factor very well, is it? So let's hope the calculator sitting right here next to me has the quadratic formula on it. Gosh, I hope so. Let's see. Program, of course it doesn't. So I've got to run and find my calculator, which is right here. Okay, don't fear, I haven't left you. Walking around the room, frantically searching for a calculator with the quadratic formula program on it. There's mine. Alright, sorry. This will take no time at all. You can just fast forward through that part. So we're going to plug into the quadratic formula. We're going to plug plug in, oh, let's go with a negative 16. Oops, negative 40 something. Negative 16, 16, and 64. And we get roots of negative 1.56 and 2.56. Okay. So there we are. T equals negative 1.56 and T equals 2.56, and we know that that's the right answer because it didn't happen in the past. And then we're just, to get the actual answer to the second question, we're just going to plug 2.56 into this equation. So let's do that real quick. I'm doing it on the side calculator. Negative 32 parentheses 2.56 parentheses. If that'll work, let's see, plus 16. Negative 65.92 seems reasonable. So my velocity just before we hit the thing is negative 65.92 feet per second. So a bad person, Santa, or someone drops a bag of sand onto your house and it's moving fast enough to probably go through your roof. And that's 2.5 seconds after liftoff. So that's the story there. Thanks for sticking with me. All right, so there's that. And there's that. And there's that. Okay. There you go. Initial conditions. We now know how to find what C is, where it is, what it's all about, what's going on with C. So, having said that, I'll stay with the traditional. Hope you learned something. If you have questions, please ask. And we'll either see you tomorrow or let's go with that. We'll see you tomorrow. Thanks for watching.